Jim, we're in Nuneaton at XYZ showroom, and I want to discuss in a little bit more detail the new 3D printing solution that you've brought to the market.
Well, first off, it's always been called 3D printing. Everybody knows it's 3D printing, but it's actually additive manufacturing. 3D printing has always been considered to be slow, and parts have always been expensive, and it's been used for prototyping and for concept models. We're now in the realms of where we can use it to actually manufacture parts in full speed, in full strength.
Does that mean really 3D printed additive manufacturing? Is it just the terminology that's changed?
Yes, it has. The terminology has changed because 3D printing was 3D printing as you would know it, with nozzles or inks and things like that. Additive manufacturing now has realised that we can make things mass customization. You can make a lot of parts that would cost an awful lot to injection mould unless you made 1 million of them. But if you only want to make 5,000 or 10,000, you can additively manufacture them just as cheaply.
So, touching on the evolution of additive manufacturing, this market, there's been a lot of talk of 3D printing, additive manufacturing for some time now. How has this changed the landscape of 3D printing? And there's metal removal machines out there, injection moulding machines that you've just mentioned. What kind of markets and what kind of machines will this new technology take away and replace with additive manufacturing?
I don't actually think it will take any machines away or replace them. There is still an awful lot of metal bashing needs to be done. There's an awful lot of injection moulding needs to be done. But if you want to make quite a high run without injection mold, without sinking injection mold tools, you now can with this new technology.
And in regards to, predominantly, you've got workshops with mills and lathes. If I was to introduce a additive manufacturing machine from XYZ, what would be its place in my workshop?
It's just another machine tool. If you have a very complex shape that you have to hold at a specific angle and machine something, you can take, nobody uses 2D drawings anymore, everybody has a 3D CAD file. So again, waving my hands about, if you've got a complex shape, you already have that surface on the CAD file. So you can take that surface and make a jig to hold it, or you can make assembly nests, or if someone says, I want 5,000 of these plastic parts and it's going to cost you £20,000 for an injection mould tool, you print them instead.
I've got a couple more questions then leading on from that, Jim. In regards to one, what is the accuracy and the tolerances that can be held? That's the first question. And the second question is really in regards to volume and quantity. Before it was just for one-offs, two-offs. Now, how quickly could it make these parts?
I've got some parts here that I could show you, but quantities are as many as you like. Really, it's how long you want to tie the machine up for. If you're looking at quality, the surface finish is getting better and better. The surface finish off the machines that we promote is much better than the competition. Also, the accuracy, we can guarantee, because this is all we're allowed to say, we can guarantee plus or minus 0.2 of a mil. If you talk to us or talk to some of the actual users, they're getting much better accuracies than that, but we can only quote the standard stated accuracy that comes with the guarantee for the machine.
And as evolution and innovation takes us to the next level, is this going to enable us to be able to redesign components as we have known before?
Absolutely. You can redesign components to have material only where it needs to be. It's called topology optimization, which means they will be much lighter but with the same strength. But there's no other way that you can make some of these parts other than additively manufactured.
So effectively we can think out the box and let our imagination run away. Now let's take a look at these components, please, Jim.
No problem. There's two here. One is made in nylon 12, one's made in nylon 12 glass filled. Two different materials, but both will be processed on the same machine.
Right, so what's the difference? What are the characteristics of both composites?
This is nylon 12, it's quite a tough material, but as you notice, you can build it very thinly and very accurately, and if I can show you, it's actually quite a flexible material. So that is something which you could injection mould, but if you wanted to modify the mould, you'd have to wait 6 weeks. You could modify one of these just by changing the drawing.
I can imagine, I can think of lots of components and parts that would lend itself to. Now the second component, this is glass filled, this is a lot more solid, a lot more robust. Can you tell me a little bit about the features of this part, please?
Well, this part has been built in nylon 12G, which is a glass filled nylon, as you say. It's been blasted and it's been dyed. If you have any nylon dye, any colour you wish, you can dye your nylon. But the main thing about this is, it'll show you again, you can build strong parts with thin walls. That part there is designed to clip onto another part and never move again. And we've already had some of these tested under some quite rigorous conditions, and they work far better than the original part.
Now, how many different variants of material is this product able to manufacture?
Right now there are 3 materials available. Nylon 12, which you've already seen, nylon 12G, which we've seen. I don't actually have a part which is nylon 11, which is more flexible but tougher, more able to withstand impact resistance. On the roadmap, we're working towards rubber-like elastomers, mixed materials, and later this year there's a machine which is coming out which will be able to print in nylon in full colour.
Now, if I was to purchase my first XYZ 3D printing machine for production, you know, I'd expect a level of support. You know, how complex are they to use, and what support would I get?
Well, support from us involves myself and our applications department, all of whom have done full training. You get full maintenance support. We give training both on site and at our own facility. You get a full maintenance package which carries on for a year. The maintenance is actually cloud-based, so we know what's going on with your machine about the same time you do, and can turn up with the right parts for doing the maintenance instead of a van full of bits and try and find out what's wrong.
A bit like Industry 4, it's already Industry 4 ready.
Yeah, it's already Industry 4 ready. One of the things that we've been asked about it being cloud connected is, well, I'm making parts for X, Y, or whoever, and I don't want that. It doesn't know what parts you're making, it merely monitors the machine.
Brilliant. Well, this has been a really informative interview. Thank you very much for your time, and please get in touch with Jim if you have any questions regarding the XYZ 3D printing machine. Thanks, Jim.
Absolute pleasure. As you can tell, I'm a bit of an evangelist.